So let's do some of these examples. We already have the valence electron count, and there are 2 oxygens, and this one was actually done in the video, but I just thought it'd be another good review. So remember, there's your bond. That gets us to 10 electrons. We had 12, so we're at 10 because of this bond. Now we're at 8, now we're at 6, now we're at 4, now we're at 2, now we're at 0. We've run out of electrons, and this oxygen right here does not have enough. Oops, I did too much. And so what we're going to do is we are just going to grab that pair. You can grab any of the pairs, but this is the pair I'm going to grab. Oh, it's not letting me. There we go. And I'm going to turn that into a bond. And that's fine. Now, sometimes people get all tied up about these electrons. Like if I saw that's right. If I saw this is actually... Once you get into structures, you would be probably more likely to draw it like that, and that's correct. If you put like this, that's also correct. So we aren't all hot and bothered about exactly where you put the electrons, as long as you put them in there in pairs, and it's obviously that we can see them being pairs. So, and like I said, ultimately, once you get really good at drawing Lewis structures, this is the form you would probably see, so don't let that freak you out if you're trying to get it perfectly boxed. We just haven't gotten to that explanation yet. All right, so in O3, we've got 24 electrons, so we've got our nitrogen. I'm going to go ahead and draw my bonds to oxygen, kind of spreading it out as much as possible. And then, so I start with 24, so I've got 22, 20, now I'm down to 18 electrons. So 18, I'll start putting them in. So I'm at 16, 14, 12, 10, 8, 6, 4, 2, 0. So that looks pretty good, right? It seems like I haven't run out of anything, except for you always want to make sure that you double check that nitrogen. He does not have enough. He's only got 2, 4, 6. So 6 total electrons. So we've got to grab one from someone and give him some more. So we'll just like grab that pair, turn it into a double bond, and then we're good to go. And again, don't stress about those lone pairs, exactly how you draw them, as long as they're in pairs. Now, maybe you thought that you would want to grab your electrons from the other oxygen, and if you'd done that, that also would have been considered correct. So that's fine too, if you did it like that. Or maybe you liked the top one. We're going to address this situation in an upcoming lesson. So if you noticed you could have done it from a few places and still had the same structure, that's great. Now I'm going to do CO2. So we have C, bond to oxygen, bond to oxygen. I've got 16 right here. So I've used up 2 here, so that's 14, and then 12. So I've got 12 left to throw around my oxygens. So 12, 10, 8, 6, 4, 2, 0. So that's one way to draw it. And my carbon only has 4 electrons around it. See, 2, 4. So he doesn't have enough. So I'm going to grab some electrons. So I'm going to grab that set of electrons there. And now I haven't fixed the carbon yet, but I've grabbed one set and that works. Now I'm going to grab a set from the other oxygen, but then I'm going to show you also what you might have ended up with. So this is actually going to be the correct picture. But if you had noticed a little bit ago when we had the 2 bonded and then the single bonded, you might have been tempted to say, okay, well, why don't I just take another pair from this oxygen? Why don't I just make that a triple bond? Because look, everyone has 4 electrons. How do I know that one's not? Okay, so you're correct. So far as we've learned so far, there's no way that you would be able to say that one was better than the other. But I'm going to let you know, we're coming up on an explanation for how you would know which one it was. You might have also grabbed it from the other oxygen. And like I said, there is an explanation and it's coming. So for now, you could have drawn all 3, but when you write it on your paper, draw this one really big and put those small because we're going to have some more comments on them very soon. Then we have our oxygen. We've got 3 of them. one's got to be in the center. And so I've got 18. So I've used up 2 of them here. So I'm at 16 and then I'm at 14. So I've counted my way down. So 12, 10, 8, 6, 4, 2, 0. Because I couldn't put any more on this one or this one because I'm already at 8 on both of those. But I've still got a problem because this oxygen does not have enough electrons. So we are going to just grab one from one side and pull it over, make it into a bond. And now you'll notice I didn't really increase or decrease the electrons. But again, if you're ever not sure, you can always count. I've got 8 here and I've got 8 here. So that's 16 plus then this little pair right here will give me 18. If you had wanted to do the other one, that is totally fine. You might be thinking, wait a second, but above, we couldn't do it. Okay, these don't look like that. But like these, they do kind of look similar. They've just got the single bond and the double bond. So there is a difference between those two situations. And it's coming up. We're going to deal with H3O in another spot. So CH, so we've got our carbon. I'm going to draw in all my bonds. So far I have I included all of my electrons? Maybe I just erased them. So that gives me 12 is what I'm seeing. So 12, and I've used up, now I'm up to 10, to 8, and to 6. So 4, 2, 0. Problem being, carbon does not have enough electrons. Remember, my hydrogens don't need electrons. So if you had started to do this problem and you were like starting to add in, it's just because you'd forgotten the hydrogens can't do that. They can only do the one, the pair of electrons on them. So like before, I'm going to grab this lone pair. I'm going to bring it down there. There we go. That's fine. If you want to straighten out these and kind of make them more spread apart, it's fine. But this works. And that doesn't have any other options. And then I'm going to look at the 2 SO3. So sulfur is 6, oxygen is 6 times 3, which is 18. So that gives me a total of 24. So sulfur, oxygen, oxygen, oxygen. So 24. And I've used up, so now I'm down to 22, to 20, and to 18. 16, 14, 12, 10, 8, 6, 4, 2, 0. Now my sulfur does not have enough electrons on it. There we go. And again, you could have put it in the other oxygens. Now, I'm going to put a big star on this one. I'm going to write FC because formal charge is going to do something different to this one. I'm going to go up to here. Remember, in this case, I was saying something. I'm going to put an R here. Well, I better not give too many of them away. But formal charge also is going to help us in this situation here. So for now, everything you know, that is the correct thing to draw. And then I'm going to go over to do the last two on this page. So we've got sulfur, oxygen, oxygen, oxygen. Oh, sorry. Let me put that one a step over. Got ahead of myself here. 6. Oxygen is 6 times 3, which is 18. Plus, I've got the 2 electrons from the charge. Don't forget about that. So that gives me 26 electrons. So now when I fill this in, I started with 26. So 24, 22, 20. That's just the middle atoms. 20. And then I've got, 18, 16, 14, 12, 10, 8, 6, 4, 2, and I have enough to put a lone pair right there. And so that's super interesting. We're going to do something with this one with formal charge also.